Good morning, everybody. Thank you for joining us this morning, especially during these difficult times. So really appreciate you taking this hour to join us here today. So my name's Quentin, and thank you for joining us for the JPro Configuring Cisco Small Business Switches for Networked AV webinar. So today we are focusing primarily on the Cisco SG Series switches. So that's the SG350 and the SG550 switches, but that is interchangeable with the older SG300 and 500 series of switches as well. And just a quick overview of what we're going to be covering today is so quick introduction of myself. So I've been with JPro since February, and prior to being with JPro, I was with the AMX distributor in New Zealand for 9 years. So I've seen technology from the infancy of HD base T through to where we are today with networked AV and having video and audio over enterprise networks. The largest deployments in New Zealand, 500 endpoints from an input to an output. So we've come, we've gone over that analog sunset and the convergence of IT and AV, and I think we are now at a position where AV experts, where we have credibility with IT professionals. So today we're just going to have a look at a couple of different topics. We've only got an hour, so we're going to have a look at configuring VLANs, access ports and membership, and why VLANs, trunking of VLANs as well. So when we need to go from switch A to switch B, so 2 switches or more, and taking the VLAN memberships and ensuring that the traffic that that is going across from switch to switch remains in the VLAN that it was assigned to. We'll configure Dhcp Server on our switch as well. So if you wanted to handle the IP addressing via Dhcp via a Cisco switch, and then finally we'll have a look at multicast management and why it's important to networked AV and IGMP, and what that means in terms of networked AV. So without further ado, I'm just going to switch over to my browser now so that we can start to log into the Cisco switch. And I'll get rid of my beautiful face as well. So hopefully everybody can see my screen now. So this is the web interface for the Cisco SG Series switches, and very familiar with all Cisco products from a web interface perspective. What I'm working with here today in terms of a switch is an SG350, and it's a 28 port switch. So going to log straight in. I do need to do a little bit of housework, which I'll explain shortly. So I'm going to log into the switch now. I have factory reset this switch so that this is fresh out of the box and what you would experience if you were setting this up. So the default configuration for a Cisco switch, username, password is just Cisco, and I'll just log in here. So be prompted to change the password as the first step. If I'm configuring a Cisco switch just for a test bench and just for I'm wanting to run a little sandbox, then I'll just stick with the defaults on there again. Obviously, it's not advisable that you do this in the real world, and that having a stronger password is recommended. So if I want to use the Cisco defaults, I just need to disable the password enforcement as well. So let's click apply there. And click OK. Okay, so I mentioned that I needed to do a little bit of housework on here. I'm just going to click at the top here where it's the saves come up. So this is just prompting me to save my configuration and that password. So I'm just going to save that. So that'll commit those changes. And I need to change the IP address of this switch. So the default IP address for a Cisco switch at the top left here is 192.168.1.254. The reason I need to change that is we're all working from home at the moment, and my Wi-Fi network is on the same network, on the one network as the switch out of the box. So just so I don't get any IP address conflicts later on, I'm just going to change the IP address of the switch. And I'm going to do that using the terminal interface. So this can be done via Telnet, it can be done via SSH, or it could be done via the console port. Out of the box, those methods of connectivity, some of which are disabled. So I need to enable the ability to telnet into the switch first of all. So just bear with me for a moment. So to enable telnet to the switch, it's under security. And then you'll have the TCP UDP services down here on the left. So you see out of the box, it's disabled telnet and disabled SSH. So nobody can actually get in other than through the HTTP service and HTTPS or through the console port on it. So I'm just going to apply that quickly. And I'm going to open up a command line interface here. So changes that I make or configuration settings that I do today, I'm going to do them through both the web interface, and where it makes sense, I'll do it through the CLI as well. And in some instances, it's faster through the CLI than using the web interface. So I'm going to telnet into the switch now. Password Cisco. Okay, so this is the command line interface, and this is the top level of the command line interface. Essentially, if I go and do a question mark, this gives me all the configuration options at the top level, and we're really configuring the switch itself from an administrative perspective. We're not actually configuring from the network perspective in terms of ports and their speeds and the protocols, and this is really just sort of the housekeeping of the switch. If I want to start configuring ports and VLANs and DHCP, we go to what we call the configuration level or the configure level. Which I'm going to do now. So from the command line, you can use the config command. And as you type a command through the CLI, if you don't know the whole command, you can start to tab and it'll complete the command for you, the syntax for you. And as you type commands, you can actually type part of a command, then a question mark, and it will give you help with what the next part of the syntax for that command is. So we'll see that a little bit later. So all I want to do at the moment is configure the IP address on my VLAN so that I don't have a IP address conflict later. So I'm going to go interface, INT, VLAN 1, and then I'm just going to go IP address, and I'll explain these later on. 2.168.2.254. I'm going to lose connectivity with my switch now, and just finally, as part of my little bit of housekeeping here, I just need to go and change the IP address on my network interface. So I'm just opening up my IP address properties in Windows here and just changing those in there. Okay, so I'll lose connectivity there, which is fine. And I should regain connectivity up here in just a moment as well. So while I'm just waiting to reconnect to the switch, I will do a quick overview of a couple of areas on the switch. One of the settings that I'm going to disable immediately on here is green Ethernet. There are a couple of recommendations out on the internet that recommend with networked AV solutions that that green Ethernet be disabled. It's a reasonably new protocol, and it's a method of saving energy on PoE switches. There are some implementations where you may have dropouts in audio, or you may have desynchronization of clocks. So a best belts and braces approach is to disable green Ethernet. So I'm going to do that. I was going to save those changes and now log back into the switch, which is great.
I thought I would just jump in here quickly and just mention that thing he's mentioning about the green Ethernet is particularly with Dante. It's not recommended at all to have it enabled on any Dante devices, and it's part of a disqualification. So he's got a very good point about it not being disabled, and it needs to be highlighted that it's a non-Dante supported thing.
Thank you so much, Malcolm. Thank you for highlighting that. Yeah, really, we can't stress enough that, if out of the box, disable that so that you don't end up later on scratching your head as to why I'm having issues with things like audio dropouts. And I've also heard of situations where we have video coming up with blank screens as well with networked AV devices. So this is our dashboard now. If you've never logged into the switch before, then you will need to change the display mode at the top here. You have a basic display mode and you have an advanced display mode. This is important later on, particularly with multicast configuration, in that some of the settings under multicast won't be visible to you if you're in the basic mode. So if you go through, complete what you see in the basic mode and miss the other steps, then your multicast operation won't be operating correctly. So over on the left-hand side here is your tree and navigating through the settings from a web interface perspective. So we have the dashboard here, which gives us the fan status and thermometer status on there. It also gives us the latest logs from the switch as well, which can be useful. Status and statistics down here on the left as well, which is a useful area and gives us software information, so the firmware versions of the switch. Now, from time to time, depending on whether we find issues with particular switches, there may be a bulletin that recommends a particular firmware version with networked AV deployments. So this is where you can find a software version. And down here, I've got the PoE power information for this particular switch as well. So this is an SG350. I have available power capability of 185 watts on there. And this is really essential for when you're deciding on the switch for your networked AV deployment. Most networked AV devices today are PoE powered, and different varieties of PoE as well, with PoE, PoE Plus, UPoE. This particular switch that I'm working with, the SG350, actually has four. You see the little yellow area at the top here, has four UPoE ports on there. So that's 60 watts of PoE power per port. But obviously, if I use all four ports there, then I'm going to consume my my PoE capability. So some of our networked AV appliances use PoE or PoE Plus, or UPoE, or PoE Plus. We don't actually use UPoE. So we have a very low low power consumption requirement, but it is essential that you calculate the total potential power requirement for all of the devices that you're going to plug into the switch before you decide on the switch. Otherwise, later on, you could find yourself needing to add PoE injectors to get yourself across the line there. So that was just a bit of an example of just a couple of areas there. So administration down here as well. So if I need to reboot the switch, I've got the reboot area here, and you can do a restore to factory defaults here as well. So you can restore factory defaults from the front button on the switch as well. Hold it for 10 seconds to do a factory reset on it. File management here on the left. So we'll be using the file operations a bit later to do a backup of my configuration as well. So we'll jump into some configuration now. And first of all, we're going to take a look at VLANs and VLAN management. So VLAN management on the left here. Why VLANs? Why do we use VLANs? Out of the box, our switch, everything is using VLAN 1. All of the devices that I plug into the switch can communicate with each other, and that would work without any problems. Where we would start to want to use VLANs is when we want to add security to my network, where I want to minimize overhead traffic. So on a VLAN, we have what's our broadcast traffic. So on a VLAN, any traffic that is sent to all hosts is a broadcast. So any device that's plugged in, say somebody does a device discovery or wants to find the host name of device, it gets broadcasted to all of the active connections or all of the clients on my network. So that can be, as the network starts to grow in size, that can start to be a lot of needless information for particular, if it's not relevant to a particular client, like my laptop. In terms of a security, we may not want our corporate users on a network to access the configuration of networked AV appliances. They may never need to see those networked AV appliances from a configuration perspective. So let's isolate them away from each other. And it makes network manageability easier as well when we've got less clients on a particular given VLAN. So it's useful in segmenting, securing networks, and managing networks. So we can add VLANs from the web interface, and I'm going to add a couple of VLANs from the web interface, and then I'm going to add a VLAN from the command line as well, so that you can see from both perspectives how it's actually done. So from the web interface, I have my VLAN settings here. This is my top level here, and I'm going to go and add a VLAN. So we have VLAN 1 here, which is the default. All ports are a member of that VLAN. So I'm going to add another VLAN here. And I'm going to add this VLAN. I'm going to give it an ID between the range of 2 and 4094. And I'm going to give it VLAN ID 20 and a VLAN name of the AV VLAN. So this is my first VLAN I'm configuring. The interface state is going to be enabled. And if I'm using SNMP, Simple Network Management Protocol, for monitoring via some form of service desk, then I can monitor my VLANs as well. So apply and then close. So I've just created my first VLAN, and I've created that using the web interface. So I'll go and create one now from the terminal. So I'll just Telnet back in on the new IP address here. So Telnet is an insecure connection method. Everything is in the clear, hence it's disabled out of the box. Telnet there is a client built into Windows. If you go to your command prompt and type Telnet, if it's an unrecognized command, then that's because Windows out of the box doesn't enable the Telnet client. To enable the Telnet client, you can go into your add remove programs in your control panel and add programs and features. And then the Telnet client is a Windows program and feature which you can tick and install. So I'm back to my command line interface here. So I'm at the top level here. First command, if I want to see what the configuration currently of my switch is, I can type a informational command called show, and this can be used to show lots of different information, but show running config will show the current configuration, live configuration of my switch. So right now, this is all there is. I've set up an interface VLAN 20 on there. I've changed the IP address on my VLAN 1 to 2.254, but very little else has been configured on here. Everything else is essentially default on here. So I want to create a VLAN from the command line interface. I'm going to go to the configure menu now, or the configure level. So if I go tab, that'll bring me to this point here. So now I'm at the configuration level. So now I can create a VLAN. So I can create a VLAN just by going in. That has now entered me into the interface VLAN 30. So if I go back over to my web interface over here and go VLAN settings, I can see that I've got a VLAN ID 30 there. So that's created that VLAN. So the int command, if I go up a level, to go up a level, you can type exit, that'll bring you back up. If I type int and then hit tab, it's the interface command. So that's working with interfaces like VLANs or my switch interfaces. If I type part of a command like interface and then the question mark, so interface space question mark, then that will give me the next syntax or next part of the command. So interface VLAN 30, working with the VLAN 30 interface now. I'm going to go back over to my web interface here now, and I'm going to be lazy and I'm going to edit it and give it its name through here. So edit and just give it a name through here. You can actually name it through the command line as well. So now I have two VLANs. I haven't actually configured those VLANs with a network address yet, and typically you have a unique network address for each of your VLANs. So if I go down on my web interface, the IP configuration here, and I have a look at my IPv4 interface, I'll see that my VLAN 1, which I configured earlier with the IP address 192.168.254 there is there. By default, out of the box, the SG switches now enable for IPv4 routing as well. So if I have multiple VLANs with multiple networks, then I can actually route traffic between those internally on the switch. So I still have the ability to talk between my networks. So I can add an IP interface for my VLANs in a couple of different ways. So I'm going to set up a network for my VLAN 20. I'm going to click the add button here. I'm going to select the VLAN that I'm working with at the top here. And then I'm going to give this interface a static address. So this is configuring the network range for my VLAN 20, for my AV VLAN. This will essentially be my default route or my gateway for my clients on this VLAN. So if they need to get to another network, a dissimilar network, then that is where they'll route their traffic to. The network mask is the subnet mask. You can use 255.255.255.255.0 if you're working with a C-class network. You can change your subnet mask if you're wanting to change your address range. If I'm just working with the standard C address class, then I'm going to go prefix length. And the prefix length is just a shorthand notation for the subnet mask. So the subnet mask here, the 255 one that I've used here, it's 4 octets. Each octet is 8 bits of data. And when I've gone 255, it's essentially turning on all the ones. So I'm using 24 bits. So shorthand is /24. I apply that. So that's my new network on VLAN 20. So I'm going to go over to the web, over to the command line interface now, and I'm going to do the same thing for VLAN 30. So I'm already in VLAN 30 here. I will exit it again just so you can see it again. So that command was interface VLAN 30. And then I want to configure the IP address for this VLAN. So the way to configure it from the command line interface is simply IP address. And like I said, at any point I can type part of a command and then hit the question mark, and it'll give me the next part of that command. So I can set this this VLAN up for a DHCP if there was a DHCP server running on there. There isn't. So I'm going to assign a static one. If I go question mark again, it'll I need to insert the subnet mask or the IP prefix length. So yeah, and then carriage return. So now I've just configured the IP address for that VLAN, for VLAN 30. So now I have a network for VLAN 20 and a network for VLAN 30. So I can start adding hosts to those networks, and there will be routing between those VLANs out of the box. I have no DHCP server running on any of my networks. Now the DHCP service could be a Microsoft server, or it could be or it could be the switch that's actually running that. It could be a router that's running on that VLAN. In the case of setting up this small network or setting up a small networked AV deployment, I could run the DHCP server directly off the switch. So what a DHCP server is a dynamic host control protocol. My laptop, when I plug it into the network, it sends out a broadcast asking for a DHCP server. If it finds one, then the DHCP server will return the settings for that particular network, including an IP address, the subnet mask, the gateway, the DNS settings for that particular network. So I'm going to configure a DHCP server on each of my VLANs, VLAN 20 and 30. So I'm going to do it through the web interface first. So I'm going to do it from the DHCP server link here. So under IP configuration still, DHCP server. Then properties, we actually need to enable the DHCP server status globally. So I'm going to apply that at the top here. So that's just enabling it globally. And then we need to start creating network pools. So network pools are the network DHCP ranges for my VLANs. So I'm going to add one here. And I'm going to call this pool. Now I'm just naming them AV and corporate just for ease of memory. And I've given the IP address to VLAN 20. I've given it 192.168.20 just for ease of memory for this. You don't have to use the same VLAN number as the network number. It just makes sense for this. So this is just the subnet range. So the subnet is the 20 or the network range, the 192.168.20, and then the prefix length of 24. And then that will populate my pool start range and my pool end range. So that means that if I plug a client into the 20 network, it will get an IP address between 1 and then 254. Now I may need to have static clients and dynamic clients on there. So static client, I've given it an IP address. I've logged into the device and set its IP address statically. So I'm going to change my address pool so that I don't have address conflicts later on by assigning hosts statically within the address pool. So to do that, I'm just going to shorten my range so that hosts will get an IP address between 100 and 200 now. So that means that I can use static addresses between 1 and 99 and 201 and 253. I don't want to use 254 because that's my my VLAN address. I'm going to apply that. And if you've got server options, various vendor options, then you have the ability to add those DHCP server options. I've just created a very simple DHCP pool here. So that's now an AV DHCP pool that I've created through the web interface. So I'm going to do the same thing from the command line interface as well. I'm going to exit out of my VLAN 20, my VLAN 30 interface. So that's the exit command, or you can use the Control Z command, which Control Z on your keyboard will return you to the top level of the switch configuration. So we're right back at the administrative top end. So I'll take option again and enter. And we're back into the config menu here now. So I want to create a DHCP pool for my corporate DHCP now. So to do that, use the IP command. And you'll see if I use the question mark, I've got DHCP there. So I'll use DHCP. And I want to create a pool and configure a pool of network addresses. So, and then the pool name, which is going to be my corporate. So I've just created a pool for my corporate users. And then I need to specify a couple of addresses. I need to specify the network address, so address, and then specify the network address, 192.168.30.0, because I'm working with a 30 network. And I've actually not put that in. And then I need to select a range of addresses for that DHCP service as well. So if I go address again, and then question mark, I can go low, which is the lowest IP address in the DHCP pool. And then high for the highest address in the DHCP. prefix in there. And so that's now created that DHCP pool. I've not set any server or vendor options in there. I've just created a really simple pool there. If I click on network pools again, you'll see now I've got a corporate network pool there as well. So off to my side here that you can't see, I've got an AMX touch panel here, which is straight out of the box. It'll be DHCP configured, so I'll just plug it into my switch here. I've not assigned at this point, I've not assigned any of my switch ports to a VLAN. So that's kind of the next step in our configuration process. So I need to start assigning some ports to my VLANs. And that's based on the roles or the devices that I have on my network. So to do that, let's get rid of the IP configuration. We have our VLAN management back up here again. And I have my port to VLAN membership. I'm going to click on that there. Right now, everything is part of the default VLAN 1, and traffic is all untagged. So what I want to do is configure a port so that it is a member of my new VLAN. VLAN 20 will start with my AV VLAN. So I'm going to go and click on port GE10, which is Gigabit Ethernet 10, and go join VLAN. Okay, so that's going to allow me to change the access VLAN that it's a member of. So I can use this drop down here, select the VLAN that it's going to be a member of, and apply that. So now GE10 is now a member of VLAN 20. What if I want to do a range of ports quickly? So I can do a range of ports quickly through the command line interface. So from the command line interface, I'll just type exit here. So I exit my DHCP configuration and go back to the config level. And to specify a range of ports, we use the interface command, $. And these are the different interfaces that we can work with here. So I want to work with a range of physical interfaces or Gigabit Ethernet interfaces. So I'm going to type the interface range, GE for Gigabit Ethernet, and then the port numbers that I want to work with. So I'm going to work with 10 again. I've already added it, but I'm going to use it again. So this would work, 10, 11, 12 would work. What that would do is that's explicitly saying, okay, add in my range, I want to work with port 10, port 11, port 12. If I want to go and say I want to work with port 10 to port 15, then I go port 10 to 15. And then I could go and say, okay, well, actually, I want to add port 23 to that as well. So that would add port range 10 to 15, inclusive of 10 and 15, and port 23 to the range of ports that I'm working with. I work with a range of 10 to 15. And now I'm working on actually configuring these switch ports. So I can bring up the help here and show the commands that are available to this particular, to my interface. This is my switch port interface. And now I want to configure these switch ports to be a member of VLAN 20. So in order to add these switch ports to the VLAN 20, the command is working with switch port. And then they're going to be access ports, and an access port is a port that is a member of a VLAN. It's untagged traffic, and it's typically a port that is connected to a host device, like a laptop, a workstation, so forth. So I'm going to switch port access VLAN, and then the VLAN that it belongs to. So I'm going to add that to VLAN 20. If I go back over to my web interface here and I go port VLAN membership here, you'll see that that's updated so that those ports are now a member of VLAN 20. Right there. So I'll just exit out of that interface range there, and I'll do the same thing for VLAN 30 here. So I guess interface range GE for Gigabit Ethernet. And I'll go 16 to 21. And I'll use the command switch port. Access VLAN. Go back over to my web interface here, and you'll see those switch ports there now. So that's isolating. If I add or if I plug devices in port GE16 to 21, it's isolating the broadcast traffic to just those ports there. So there's not unnecessary traffic getting to hosts that don't need it. It's not relevant to. So from there, I may have multiple switches on my network, and I need to maintain those VLAN memberships across switches. I don't want to have individual ports connecting from one VLAN on switch A to the corresponding VLAN on switch B. What I want to use is a trunk, and that trunk is going to carry multiple VLANs across it. It's going to tag the traffic across the trunk, so that if a host on switch A wants to reach a host on switch B, their VLAN information, VLAN 20, is tagged across the trunk. Tags it saying that this traffic originated on VLAN 20. When it reaches the destination on switch B, it will be able to pass that traffic to VLAN 20 on the corresponding switch or on switch B. So in order to create a tagged or trunked port, I should say, we can do that through the interface settings on the web interface, and we can go and edit one of our switch ports here. So we're working with .1Q or 802.1Q trunking, and I'm going to edit that switch port there. So I'm editing the switch port GE28, so port 28 on my switch, and I'm changing this now so that it is no longer an access port as a host port. It's now actually going to be a trunk. I'll apply that there. I'll close that, and that's now a trunk port there. So if I look at the port to VLAN memberships down here, my web interface now, I'll see that this is a trunk port and it's tagged for VLANs 20 and 30 on there. Administratively, some of my other VLANs are currently inactive on there. So it's a native member of VLAN 1 and it's tagging 20 and 30 on there. To do this on the CLI, command line interface, we can go configure an interface. So config interface GE, and I'll work with 27. And it's a very similar command here, switch port. Now I'm changing the mode that the switch port is in. So switch port mode, question mark, to show the options, and trunk. That port is now a trunk port, and it's allowing all VLANs across it at the moment. If I want to refine the VLANs that are allowed across that trunk port, I use another command in order to disallow VLANs across that trunk. To do that command, it's trunk, switch port trunk, allowed VLAN, and if I go none, that will remove all VLANs from that trunk. Go back to my web interface here now, you'll see GE27 currently allows no VLANs across that trunk. I can use the command again, go VLAN, and now I can go and add specific VLANs to that. So I can add VLAN. And if I go back over to the web interface here, you see that 20 and 30 are now allowed across that. So traffic from ports that are members of VLAN 20 will be tagged. The traffic will be tagged across the trunk, and it'll be destined for VLAN 20 on switch B. So that's how to create a trunk. We'll sort of move on from there and start having a bit of a chat about multicast. This down there. Sorry, I had my touch panel, which I will plug into VLAN 20. I'll just wait for that to boot back up again, and I'll just show you the DHCP table and thereafter. So multicast. So we'll start having a look at multicast now. So why multicast? Why do we need to use multicast management, and how does multicast management work? So multicast management is essential in networked AV deployments, particularly where video and audio are where video really we're expecting video. And AMX's SVSI networked AV solution, they're sort of their go-to 1080p lowest compression, lowest latency series, the N1000 series. It has a bandwidth usage of 780 megabits locked per stream on there. So if we're not managing multicast, then we can quickly overwhelm a network. And the reason for that is, so just a bit of a quick bit of homework in terms of different types of traffic on our network. We've got our unicast traffic, we've got our broadcast traffic, and we've got multicast traffic, or traffics that we have. Unicast traffic is, say I want to download a file from a file server, I request it from the file server, and that's a one-to-one, it's point to point. If I want to send a message to my whole network, my broadcast domain, I want to discover a service, then I send out a broadcast, and that's one to all. So that's sending out to every client on my network. And then multicast traffic is one to many. So what we mean by many is those that request the traffic from the originating source. So the originating source, the encoder, and networked AV terms, the encoder is sending its video, its audio, it's sending it to a destination address. That destination address is a multicast address. It's not any one host address. It's not a laptop. It's not a server. It gets sent to a multicast address. And if we don't manage the multicast memberships or configure it, then what happens with multicast is that is then forwarded to all devices on my broadcast domain. So everybody gets that multicast traffic, whether they want it or whether they don't want it. So it operates very similar to broadcast when it's not managed. And if I have two encoders on my network, and say the N1000 series, then I'm going to flood a gigabit port immediately on there. So if you've ever done a demo in a customer's office and plugged an encoder into, or a couple of encoders into a network just to see whether or not it's managed, and people's heads start popping above cubicles, wondering why their computers have just stopped working, then that's generally a good sign that multicast hasn't been configured on the network. So the way that multicast configuration operates is we use a protocol called Internet Group Management Protocol, or IGMP. And with most networked AV solutions, we're working with IGMP version 2, specifically, the SVSI product range, AMX's SVSI product range. So what happens with IGMP is that there are messages, there are leave messages, join messages that are sent from hosts to join a multicast group. So the encoding device is sending its traffic to its multicast destination, and as a device, a decoder or an endpoint, I am requesting to join that group. I'm sending a message. Now, the switch, most managed switches nowadays can operate with what we call as a snooping switch, but can also operate as what we call a Querier as well, and we'll go through that now. So to start configuring multicast management on our switch, we need to enable it globally. And on the SG series switches, the bridge multicast filtering status must be enabled here. And we can leave the other settings as default. Just apply that there. If you don't enable that there, I disable that, and then I go down to my IPv4 multicast configuration and snooping. Get a message at the top here that says snooping, IGMP snooping is only operational when bridge multicast filtering is enabled, and it's currently disabled. So if you miss a setting, then you're not going to have your multicast management isn't going to be operating. So I'm just going to enable that there, and I'm going to apply that there, Now, if I go down to my Igmp Snooping, we'll see that that says that it's now enabled. Okay, so globally, I've enabled it. So snooping, what is snooping doing? Exactly what it states implies. It's snooping at traffic on the switch from a layer 2 perspective. It's looking at who is requesting multicast traffic. And based on the join requests, it then can build a table of who needs multicast traffic, who wants to be a member of multicast groups. And then it can build a forwarding table and start forwarding multicast traffic. It doesn't care about maintaining those groups though. So there is, without the configuration of what we call a Querier, you will get into a situation where, yes, the switch will start forwarding multicast traffic to those that requested, but after a period, you'll get dropouts because the timers, and there are timers that operate from a host perspective, the timers will the timers will expire. The host will be removed from that multicast forwarding table, and then the traffic will cease. The host will rejoin it, and the snooping switch will re-see that. It'll start forwarding again. But we need a Querier to maintain those groups, and we'll set that up shortly. So Igmp snooping status, we need to enable that from a global perspective as well. Querier status enable. So I'm going to apply those settings there. And then we have down here, we have the Igmp snooping tables for each of our VLANs here. And we need to configure this from a VLAN perspective. So my multicast traffic is going to operate on VLAN 20 here. So I'm going to select the little radio button over here on the left, and I'm going to edit this setting here. And it's just as easy to configure this through the web interface as it is through the CLI. It's actually easier just to do it through the web interface, I find. So I'll just do it through the web interface today. So Igmp snooping status, we want to enable the snooping on that VLAN. So we're looking for Igmp messages. The MRouter port is our MRouter port is the port that is connected to our Igmp Querier. And the Autolearn function is essentially what happens is the Querier, and I'll explain this a little bit more soon, sends periodic messages. It sends messages for specific groups and for all groups. And when a switch port sees those messages coming in, it will automatically or auto learn that port is the MRouter port. The MRouter port stands for Multicast Router Port. I'm going to disable that for now because we can statically assign that, and our switch, the switch that we're working on here, is actually our querying switch as well. Immediate leave. Immediate leave is, it's not actually part of the original Igmp version 2 scope or the RFC. Immediate leave is something that is actually tacked on, that is implemented slightly differently, can be slightly different from vendor to vendor. It's either called immediate leave or fast leave. And what it's doing is, so when a host leaves a multicast group, they send the leave message. That leave message is forwarded to the Querier. The Querier then sends a group-specific message to find out if there are hosts that still are part of that multicast group. If they aren't, then the snooping switch breaks down that that multicast group. There can be a period though, if I'm saying with a decoder, with a networked AV decoder, that I switch from TV1 to TV2, that because it immediately, and we do instant switching, we switch from TV1 to TV2 in an instant. If we don't have what's called immediate leave enabled, we're actually receiving traffic from both multicast groups until the timer expires for the Querier. So if, again, with some of the higher bandwidth consuming networked AV appliances, we could be consuming the gigabit port on our decoder. So immediate leave is essential in deployments with anything that is going to potentially consume over a gigabit within a short frame of time. So within 1000 series at 780 megabits per stream, this is imperative that you enable immediate leave. So what this does is when my decoder sends the, I want to leave this group TV1 and I want to join TV2, the snooping switch sees that leave message and then it immediately removes it from the group address table. It suppresses the message, it just removes it from that table. So it's a break before make. So it breaks the connection to TV1 and makes the connection to TV2. So it means that I'm never consuming more than my gigabit bandwidth on that switch port. So I want to, moving on from immediate leave, I want to enable the Igmp Querier on my switch. So the Querier is responsible for periodically sending out group-specific messages or general messages to find out who's receiving multicast and essentially reset timers so that so the snooping switch can maintain who's receiving multicast traffic. So every network with networked AV or multicast traffic that we want to manage needs to have a Querier on there. So I'm going to enable the Querier on the switch, and most managed switches nowadays that can operate at layer 3 can operate can support an Igmp Querier. The query election process here, which is enabled, I'm going to disable that. And what that means is that if I've got multiple switches on my network in a large switch-to-switch deployment infrastructure running multicast, there is a query election that occurs, and the switch with the lowest IP address wins. Where that can cause issues is if you've got 5 encoders connected to switch A, and that's the switch that we would like our Querier to be. It has an IP address of 254, and when we enable it, that's fine. The traffic stays there. I add another switch to my topology, switch B, and that has lower address of 253. In the election process, that switch 253 or switch B becomes the Querier. With multicast traffic, the messages are not the only things that are forwarded to the Querier. All multicast traffic is forwarded up the MRouter port. So that means the 5 encoders on switch A that did see switch A as their Querier and was configured as a Querier, when I've added switch B and it's become the Querier, those 5 encoders are all forwarded, their multicast traffic is all forwarded up the MRouter port towards the new Querier. So for more robust networks, it's recommended that you disable the Querier election, and the Querier election can operate differently between different disparate vendors as well. So it's recommended that you disable that and specifically imply which switch is going to be the Querier. So I'm going to set Igmp version 2, which is what we operate with most of our networked AV appliances. And the Querier source address is going to be user defined from here. And I'm going to select my VLAN 20 here, which means that my switch, my VLAN 20 here, is actually operating a Querier here, which means that it's keeping all of my Igmp messages local, and all the multicast traffic is going to be local to this to the switch as well. And then I can apply that. So that's now operating there. The next step here is we need to configure some specific VLAN settings here as well. So down here I have my Igmp VLAN settings left here, and I'm configuring the settings timings per VLAN. So with networked AV, the only configuration changes you need to make here are the router version 2, and the query intervals. This is the periodic predetermined periodic length for the queries that are sent out. So I want to keep this nice and short, so that we minimize the risk of video dropouts or issues. So the lowest we can have with the Cisco switches is 30, so we're going to apply that there. I'm just going to close that there. Okay, so we've configured the snooping switch. It's now looking for messages on my network for join requests, leave requests on there. I've now configured a Querier that's operating on the switch. If I go over to Wireshark here, which is a network monitoring, network analyzing tool, I have my Ethernet adapter here. If I double click on that there, then I should start seeing query requests in there. I'm actually plugged into the wrong network at the moment. I'll come back to that at the end of this. So I'll go back to the configuration. I'll come back to Wireshark at the end of this. And so there are a couple of other settings that we want to configure on here. So the multicast router port, if we do have another switch that has been configured as the Igmp Querier, we can set the MRouter port statically. The dynamic is the Autolearn, so it automatically learns where the Querier sits or the MRouter port sits. So we can specify which port is the MRouter port if we want to. Unregistered multicast is the last setting that we're going to one of the second to last configuration option I'm going to have a look at. So the unregistered multicast is when a multicast originating device, an encoder, sends traffic to a multicast destination address. If nobody has subscribed to that traffic, it is deemed as unregistered multicast. The switch doesn't know about it, doesn't care about it. It's not managing it. It's unregistered until such point as somebody joins that multicast group, and then it becomes then the snooping switch becomes aware of it. So out of the box, unregistered multicast is handled typically in this way. It forwards to all ports. So you see under unregistered multicast here, we've got forwarding and filtering on all ports. So what that means is that if I have one decoder and I have two encoders, the decoder can only subscribe or join one multicast group at a time. So if it's not subscribed to encoder B, so I've got encoder A, encoder B, then encoder B becomes unregistered. Nobody's requesting that. So what's going to happen is all the traffic off of encoder B by default is going to be forwarded to all switch ports. So we filter it so that an unregistered multicast does not get forwarded to all switch ports. And again, I'm just going to use the web interface for this. It's live clicking radio buttons.
So I thought I'd make mention here that if you enable unregistered multicast filtering on a Dante device that your computer is plugged into, so your computer is trying to do Dante controller and you're plugged into the interface, if you enable that unregistered multicast filtering, it filters the Dante data to your laptop and you won't see any of the Dante devices, or it will start freaking out quite a bit. So as much as it is good to enable for a lot of other reasons, just bear that in mind with Dante, particularly your computer that's looking at the connection. It's not good for it because you lose all the data because your computer's not requesting that information, so it doesn't pick it up. It's something Dante controller doesn't work nicely with.
Yeah, thank you, Maldwin. That's a very good point. And my experience is mainly around network AV with SVSI's AMX's SVSI solution, and Dante's. It's a little bit it's a little bit newer to me, and obviously we've come across this this problem when we've been configuring systems before. And so by filtering out that traffic, yes, as Mold was implied, you can run into issues with device discovery with Dante and configuring Dante routes and so forth with Dante controller. So in order to mitigate that issue, you could just, the port that you have configured for your laptop or that you plug your laptop in, you could change that to a forwarding port. So it would forward all unregistered multicast. Or alternatively, you could use the IP multicast group address over here. So this is the group address tables here. So these are the multicast groups that exist on my network. I have a multicast group on 37.1 or 239, 255, 37.1 and 165.1. So this is actually the video from an SVSI encoder and the audio from SVSI encoder. So that's the completely independent multicast streams, which is great for keeping audio at a real low bandwidth for switching and for management through networked audio devices. If I look at the details for this group here, then I can actually see where this multicast traffic is actually being forwarded to. So on port GE12, I actually see that I have a member on there, or a dynamic member on there, which means that I have a decoder on port 12 that has requested that traffic. So we can actually create manual multicast memberships. So this is useful for those situations where we need to implicitly add members to specific multicast groups. For things like MDNS and PTP, we can actually go and add specific multicast address groups. So on VLAN 20, we can add the IP version 4 multicast address here. So one of the IP addresses that you might use for this is, I'm just going to flick over here, is for your MDNS, so Multicast Discovery. So I will go and add that address in there. So this is actually making the snooping switch aware of this IP address, this multicast group here. And then I can specifically add members to that group on specific ports. So if I go details here, I can statically assign members to that specific multicast group, which means even when nobody is subscribed to a multicast group and it's unregistered, I've actually forced a manual registration of that multicast group. So if there was any traffic on that 224.0.0.251, it would be forwarded to that port there. So there are addresses for MDNS with the 251, PTP on 129 through to 132 on there. And I've actually got a link to which network ports does Dante use on Autonate's website. It's useful. Okay, so that's now configured on there. So I'll just save that configuration. So at this point, we have operational multicast on there. We can see the groups that are being built with the 20, and we saw the details on there. And we saw that I only had one dynamic member on there, which means that traffic isn't going to be forwarded to other ports. So at this point, I want to ensure that I've saved my configuration, because there's two modes that the switches run in. Most managed switches, there's a running mode and a startup mode. So the running mode is my live configuration, and then I have to commit that configuration to the startup so that when I reboot the switch, it's going to start with the startup configuration. By clicking the save at the top, that commits the configuration to the startup. You can commit it from the web interface as well. So if I do a copy, copy running config to startup config, and hit enter, overwrite the file, yes. So that's copied my running configuration, what I'm running right now, to my startup configuration. If I then go show the startup configuration, this will now show the full configuration. That was a bad idea. Don't maximize that. And this is actually the syntax that you would use if you wanted to complete this configuration from the command line. Command for command. This is how you would configure it. So as you can see, my configuration is a lot larger than it originally was. There's actually quite substantially more to it. If I want to back up this configuration, so I might want to create a baseline that I can use with other switches later on. If I have a standard solution set that I sell with a particular SG series switch, I can create my baseline configuration and modify it from there. And finally, to do that, over at administration, we have file options here. We have backup file option radio button there. We can back up our startup config or our running config from there, and we can apply that. And that downloads a text file. And here's that text file. So there's your configuration. So if you sometimes use 10-port switches or 20-port switches, you can modify this configuration for the switch ports the number of switch ports that you have. And guys, that's really as much time as we have today. That's our hour. So I will go over to the Q&A session now, and we'll open that up. If you've got any questions, then please do ask. I really appreciate your time today in these difficult times, and I hope you're all safe and sound in your bubbles at home, and managing to get some productive work done. Thank you so much.
So I have some difficult questions for you, Quentin, that are common ones, and maybe if you guys want to stick around, you'll hear some of these. But one of the questions I have was with the VLAN setups, is it recommended or common practice to split the audio and the video VLAN? And if it is, how do you deal with AES67 coming off video devices? So just a short idea of how that would work and best practice from that side.
So from my understanding nowadays, that particularly with AES67 and SPSI devices, that we would have our AES67 source, video sources and audio sources on the same VLAN. With Dante devices now, they do operate, they will operate on the same VLAN too. There was issues, or there was particular circumstances where Dante uses the same multicast destination address range, the 239.255, so you could get IP address conflicts or multicast address conflicts between Dante devices and other multicast devices like SVSI. But that, I believe, has changed. You can change the second octet with Dante so that you don't get those conflicts. So there are specific instances there. If somebody needs to break the audio into another VLAN to distribute it throughout different areas of the building, then certainly, we can break it to it, tag it and break it into other VLANs, but at that point we're needing to do multicast routing with what's called protocol independent multicast, and if we need to get it back into to specific VLANs as well.
So that's interesting to know that the multicast address can conflict. Beyond the IP address, we also have to consider what the device's multicast address are and whether they are replicating on the same address or not. How would one find out if they are or aren't, if there was no interface or user management thing that tells you this is the multicast for these devices?
Well, okay, so from an AMX perspective, put my AMX hat on for a sec. From their perspective, they do make it quite clear as to what the multicast address streams are. It's actually in the web address, the web configuration, what the audio and video multicast destinations are. And there's actually a I'm on the wrong network. There's actually a calculation that's available for that. There's actually a spreadsheet which will give you all of the multicast addresses based on the stream number that you assign. So that's from an SPSI perspective. From a Dante perspective, then you could then you'd have to use something like Wireshark to analyze the traffic on your network to see where that traffic is destined to. So you can run Wireshark, and I've just flipped over to another network here. Let's see if this actually starts.
So this is the first time that any of you are seeing Wireshark. It's a free program that is used to analyze traffic on the network. It kind of basically digs up the packets and you can dig into it. It's very intense, the amount of information it can give you, but it is a very powerful tool in understanding that it is going to give you a lot more than you're expecting. But as Quentin's showing, you can see a lot of information rolling through the screen.
So in order to be able to see Dante traffic on there, you would need to do what's called port mirroring, mirror the port of the devices so that you can see the traffic from those devices, and then you can add filters within Wireshark to filter out specific traffic types. So in the case of, say, Dante traffic, we can filter it based on the destination port. So Dante traffic has a destination port of 4321. So we would filter that out so that we didn't see all of that other spurious information, and we only saw what we needed from there. Conversely, if I just want to see messages and ensure that IGMP is operating correctly, then I can add a filter for that as well up here. So I've just got a protocol filter that I've entered in, which is just filtering so that I'm only displaying IGMP messages. So these are the messages that originate from the multicast, from the IGMP Querier, which is on 192.168.20.254. We have general queries, and we have group-specific messages as well that are being generated from there, and any messages from the hosts from the actual devices are sent back as well.
Good. So another question I have is, which I come across quite often, is you go to a switch and you have no idea what the web IP address is to access the switch. What other means can people use to access a switch if you don't know the web IP address of that switch, or you're not able to find it somehow?
If you've got the console cable for them, they've got an RJ45 on the back of the switch, which is a console port, so a serial port on there, and I think 38. What's the
throwing out a few little harder ones. No,
I'm just trying to remember what the default baud rate for a Cisco switch is off the top of my head. So you can use the console port on the back of a Cisco switch to use a terminal session with it if you don't know the IP address of it. And if somebody's overzealously added or changed passwords on the IP connectivity to the switch, you could use the console port as well. So you can do that through something like PuTTY or through MOBA term and use an RS-232 connection to the device.
Good. So another thing is something we come across with video products with video over IP is jumbo frames. One, I know it's quite convoluted to find it inside the Cisco switch configurator, and then the other thing is just a brief explanation of what a jumbo frame actually is.
So jumbo frames are important with AMX head again with N2300 series and the payload that they expect or that they have in their IP frame, in their data frames. So it's way so jumbo frames are a way of effectively lowering CPU utilization on a network switch. So every frame of data that goes out has a certain set size on there, which I think is 9600 bits, and with jumbo frames, we're increasing the size of that frame. So for every frame, the switch has to process them individually. Which, if you've got a really busy network, then that can be quite a that can be quite a load on the switch's processor itself. After all, it is a compute device, and it is having to process that. So jumbo frames increase the size of the frame, so the switch has to process less frames. And particularly in the case of 2300 series, that requires jumbo frames to be enabled.
So a nice way of looking at it really is that instead of sending individual smaller packets the whole time, which is how a switch normally would run, a jumbo frame is a feature that you have to activate by force that sends a much larger packet, a very abnormal packet. So from an IT world, they would consider it as dodgy. They wouldn't want it on their network, or computers won't like it. But for video over IP protocols, when we want to send frame accurate, frame by frame picture, large amounts of file like 4K video, very low compression, it becomes a really big file, one big packet that has to get forced down the network. So it's abnormal to switches to do it. That's why you need to activate it for certain things. And video over IP is something that suffers with, or not, is something that requires that enabled most of the time.
That's right. So on the Cisco switches, you can enable the jumbo frames and port management. Port management and jumbo frames at the top there. So that requires a reboot of the switch in order to enable that.
And then another question that gets asked sometimes is DHCP for audio over IP or video over IP products. Should we be using it, or should we be assigning static addresses, fixed IPs to devices?
That's a good question, because you can either do it, DHCP, and whatever address you get is what you're given, or then you can go and do DHCP reservations as well. So reserving IP addresses based on MAC address. So in large deployments, it can become unwieldy managing static IP addresses. If you're talking about hundreds of devices, whether it be a network AV device or just an AV control appliance, or you can end up with, because you're going to have a spreadsheet, right, with all the IP addresses, all the static addresses for all of those devices. For a most robust deployment, yeah, that probably is still in my eyes, and I'm happy to have other people's opinions as well. It's probably still the belts and braces approach by statically assigning everything. You know what the IP address of that is. Somebody's not going to muck about with the reservations. The other thing is, if you're running a DHCP server and it's not running on the switch, if it's running on, say, a Microsoft server, and that DHCP server goes down, and then maybe there's a power outage, the switch comes back up, your DHCP server is running in a VM, and that takes longer to come up. Your devices boot up, they're looking for their IP address, and they've requested it, but the DHCP server is up. Those devices don't get the address. They don't get an address. They're not controllable. They get a self-assigned address, which is a 169.254 address. So, from a belts and braces approach, if we had statically assigned those devices and my switch came up and my network infrastructure was up and running, I'm not reliant then on that DHCP service. I can still operate my environments.
Yeah, it's also worth noting in the live industry, this is up to debate, as you said, but in the live side, people prefer to use Dante unassigned IP addresses, because as a device comes off or online, if it doesn't have a IP address, be it not fixed and no DHCP, so using its normal standard IP address that it comes up with itself, it's considered a safer method, as you can move a gear around to different clients and they'll not have to figure out what the new IP address is that you've assigned it. But that is, it's a very good conversation, which expands much longer, but he has a very good point about if you lose the DHCP server, you won't have any control over those devices for a while. I think that's about us for today. If there isn't any other Q&As that popped up during this time, but I think we're about at the end then.
Yeah, thank you so much, everybody. Appreciate you joining in. If you have any questions or just want to have a chat, then my email's up there. Please feel free to reach out to me. Thank you.
And it's worth mentioning that we will also have this video available for you guys to use later on. So as much as you've seen it now, you probably want to recap it at some point or on the day of a job. This video will be uploaded, so you'll have access to it in the future.
Thanks, everyone.